All right, so we said that there are two ways that energy can be transferred. If energy is transferred as a result of putting something hot in contact with something cold, that heat transfer is called heat. And any other way of doing a transfer of energy is called work. Okay, so let's talk about pressure volume, what we call pressure volume work. That's the type of work that we're mostly going to be dealing with. Okay, and so PV work refers to what's called pressure volume work. Is that the last? Oh, okay. Pressure volume work. Okay. I think I have the wrong slide. Ah, here. Okay. So work, okay, is energy that's transferred due to the application of force over a distance. So the value of the work that you're doing, if you exert a force over a distance, is just the product of the force that you're exerting times the distance over which you exert it. Okay. Now we're going to be primarily concerned here with what's called pressure volume work. And that refers to the energy that you transfer between the system and the surroundings when the system either expands or contracts. Okay, when a system is expanding or contracting, what does that mean? There's an unbalanced force at the boundary between the system and the surroundings. Okay, so the amount of work that's involved there, the amount of energy that's transferred during that process of expansion or compression, is equal to the external pressure multiplied by the change in the volume. So this is P external times delta V. Okay, change in volume. So we need to adopt a sign convention here. Okay, and if you have a system that's expanding, okay, if the system is expanding, it's doing work. We say, okay, uh, it's working against an external pressure. Its energy is going to drop. Okay? If you're doing work, you lose energy, right? So expansion causes a decrease in the energy of the system. So we say work is being done by the system. So since the system is losing energy, we've adopted a convention so that in that case we assign a negative value for the work. So when a system is expanding, we say work is negative. Okay, the amount work there in that case is the amount of energy that is the amount of energy that's transferred between the system and the surroundings. Now, if you're compressing the system, then that leads to an increase in the energy of the system. Okay, and so work, for example, if you were to squeeze a gas, you're going to cause its temperature to increase because you're transferring energy to your gas. Uh, So work there is said to be done by an external force on the system, and that leads to an increase in the energy of the system. So when a system is compressed, we say work is positive. So to make so that the value for work that we calculate, the algebraic sign is consistent with that notion of work being positive or negative, positive for compression and negative for expansion. Our formula for work is written this way. Work is negative, there's a negative sign in front there, times the P external times the change in volume. Okay, let's see if that's consistent. What happens if a system expands? V final minus V initial would be positive or negative if it expands. Final volume is higher than the initial volume. So this number is bigger than the number you're subtracting. So that's positive, right? So if your delta V is positive, a negative pressure is always a positive number. So a negative times of a positive times a positive will give you a negative value for work. So expansion, negative work. Compression, what happens to compression? Final minus initial volume would be a negative number, right? For compression. So that's expansion. This is for compression. And so negative of a negative number will give you a positive number. So work is positive for compression. So let's apply that simple formula to this question. Calculate the work involved when the volume of a system changes from 546 to 382 liters under a constant external pressure of 1.5 atmosphere. What's the formula for work? Negative P external times delta V. What's our external pressure? 1.50 atmosphere. And what's our volume change? Final volume is, what's our final volume? 382. What's our initial volume? 546 liters. So what is this answer? Okay, this is negative, right? And there's a negative in front here, so the whole thing is positive. 246 liters times atmosphere. Positive. Should it be positive? Is the system expanding or contracting? From 546 to 382. 546, 382. Compression. So work is positive. That means the system gained energy. So that energy transfer is classified as work. Okay? So a pressure unit times a volume unit, liter times atmosphere, is a unit of energy. So what is that in joules? You can show that 1 liter times atmosphere is equivalent to 101.325 joules. So it's a good conversion factor to know. Okay? So that's 101.325 joules. So if we want to change this to joules, what would this be? 246 times liters times atmosphere. 1 liter atmosphere is 101.325 joules. So what would that be? Times 10 to the 4th joules. Okay? So you may be wondering, how did a pressure unit and a volume unit end up being an energy unit? Think of it this way. Remember we said force times distance is an energy unit, right? Force is what? Newton. And distance is meters, right? So a Newton meter is what we call a joule, an energy unit. What if you have a pressure unit times a volume unit? What's the unit for pressure? What's the definition of pressure? Pressure is force per unit area, right? You divide the total force by the area on which it exerts. That's pressure. So the unit for pressure is newtons per square meter. Okay, what's the unit for volume? Length times length times length. So it's cubic meter. So what's Newton per meter squared times meter cubed? Newton times meter, which is a joule. Okay, so a pressure unit times a volume unit is a joule. So this pressure unit right here is called a Pascal. Okay, and that happens to be related to the atmosphere. Atmosphere, if you recall from your earlier classes, 1 atmosphere is 1.01325 times 10 to the 5th pascals. Okay, that is the pressure due to a column of mercury that is 76 centimeters tall. Okay, and you can calculate that pressure to be equal to this many pascals.